Hello students, welcome to Breedmark Academy. Myself LS Nanda. Now in our previous year question series of Jee Main and Jee Advanced, this is the next problem that I am going to take today. It's a question based on the topic of inverse trigonometric functions. It says, considering only the principal values of the inverse trigonometric functions, we have to find the value of this particular expression. Now this expression seems to be a large one, but actually all the terms of this expression are interconnected. To find this interconnection, I am assuming this particular value as theta. Now since we know that every inverse trigonometric function is actually an angle, so I have taken this value as an angle theta. Now when I take tan on both the sides, I will be getting tan theta equal to root 2 upon pi. So if I square both sides, I will be getting tan square theta equal to 2 upon pi square. Take the reciprocal on both the sides, you will be getting cot square theta equal to pi square by 2. Now students, we must also know the range of theta, because in solving such problems, the concept of range is very important. Now we know that the principal range of tan inverse x is from minus pi by 2 to pi by 2, that is open interval minus pi by 2 to pi by 2. Minus pi by 2 to 0 is reserved for negative inputs, and 0 to pi by 2 is reserved for positive inputs. Now since root 2 upon pi is a positive value, so that means theta must lie between 0 to pi by 2. But to further restrict this particular interval, what I am doing, I am using a basic concept, and that is, we know that tan inverse x is an increasing function. Why I am saying this? Because we know that the derivative of tan inverse x is 1 upon 1 plus x square, which is always positive. Fine. And since we know that if f dash x is positive, then the function is increasing. Now we also know that root 2 upon pi is smaller than 1. So that means tan inverse root 2 upon pi will be smaller than tan inverse 1. Fine. Now tan inverse 1 is how much? It is pi by 4. So that means tan inverse root 2 upon pi will be smaller than pi by 4. So this means that theta must lie somewhere between 0 to pi by 4. Now this particular range will help us to solve this question. Now we move to the first term. First term is 3 upon 2 into cos inverse square root of 2 upon 2 plus pi square. Fine. Now students, to solve this, what I do, inside the square root sign, I divide up and down by 2. So I'll be getting 1 upon 1 plus pi square upon 2. Now what was pi square upon 2? It was cot square theta. So that means this becomes cos inverse square root of 1 upon 1 plus cot square theta, which means 1 upon cosecant square theta, which means sine square theta. That is cos inverse square root of sine square theta. Now square root of sine square theta is not sine theta, it is mod of sine theta. Always remember that under root x square is not x, it is mod of x. Now since we know that sine theta is positive because theta lies in the first quadrant, so that means we can remove the modulus sign and just write cos inverse sine theta. Fine. Now sine theta can be replaced by cos of 90 minus theta. So this becomes 3 upon 2 into cos inverse cos 90 minus theta. Fine. Now students, we move further. Now the expression for the first term becomes 3 upon 2 into cos inverse cos of pi by 2 minus theta. Now to get its value, we must know the range of pi by 2 minus theta. Since we know that theta lies in 0 to pi by 4, so I can say minus theta lies between minus pi by 4 to 0. If I add pi by 2 throughout, I will be getting pi by 2 minus theta greater than pi by 4 but less than pi by 2. Now students, we also know that cos inverse cos x is equal to x when x belongs to closed 0 to pi. Right? Now obviously pi by 2 minus theta satisfies this particular interval. So that means the value for this term becomes 3 upon 2 into pi by 2 minus theta. Or I can say this is 3 pi by 4 minus 3 theta by 2. Right? Now we move to the second term. And this is 1 upon 4 into sine inverse 2 root 2 pi divided upon 2 plus pi square. Now to solve this value quickly, what I do, I divide up and down by pi square. So it becomes 2 into root 2 upon pi divided upon 1 plus 2 upon pi square. Now since we know that root 2 upon pi is tan theta, so this becomes 1 upon 4 into sine inverse 2 tan theta divided upon 1 plus tan square theta. Now students, we know that 2 tan theta upon 1 plus tan square theta is the formula for sine 2 theta. So it finally becomes 1 upon 4 into sine inverse sine 2 theta. And we know that sine inverse sine x is equal to x if x lies in closed minus pi by 2 to pi by 2. And since 2 theta is lying between 0 to pi by 2, so obviously 2 theta satisfies this particular interval. So that means this is nothing but 2 theta upon 4 or just theta by 2. Fine. So now we add all these values and get the answer. So 3 pi by 4 minus 3 theta by 2 plus theta by 2, and the last term was obviously theta. So just add all of them. The answer comes as just 3 pi by 4. Fine. Now students, you can just convert this into decimal by putting the value of pi as 22 by 7. The answer correct up to 2 places of decimal comes as 2.36. Fine. Now the next problem I will be posting tomorrow. So keep watching my videos and enhance your knowledge. Thanks.